Welcome back everybody. I am a teacher from in the Online Academy. In today's video, the topic is experimental designs and separation techniques. This is basically chapter number 21 of the ongoing series for the Cambridge Chemistry 0620, and in today's video we'll be having a look at this chapter and the contents of this chapter which we'll discuss today are, first of all, we'll talk about experimental designs and the apparatus that are required for different experiments in our chemistry labs, and then we will talk about precision and accuracy. We will name the appropriate apparatus for measuring different variables, and in the last we will talk about the separation and the purification techniques, which include chromatography, we have distillation, and we have some more filtration and evaporation. So without further ado, let's just begin, and let's first start with the experimental designs. Like, first of all, we'll talk about planning and experimental investigation. Like, there are so many steps while considering or while planning an experimental investigation, and those steps are: the first one is identify the problem or identify the data requirements that we are needed. Like in identifying a problem, we will define the issue you want to investigate or determine what data is needed to answer your research questions. The second step is formulate a hypothesis. Hypothesis is basically a tentative statement related to the issue or the problem, and you have to propose a solution to the problem in formulation of a hypothesis, and this one is the second one. And you have to choose methods and tools you will use to gather the data. And then the third one, you have to identify the variables, determine which variables will be dependent, which are independent, and which are the controlled one. So we will also explain these variables in the previous one. So you have to identify the three types of variables that are included there. We have dependent, we have independent, and controlled variables. And the fourth one is the designing the experiment, and in that create a plan for testing your hypothesis. And in the fifth one, we have to collect the data by using the appropriate tools, and you have to choose some methods that are required for calculating any type of data. And next, the sixth is the analyze the data, examine the data to draw the conclusions. And in the last, we have to state our conclusions or summarize what you have learned from the experiment. So these are the steps that are involved, and you can see here, this is the diagram through which, or the steps through which you can easily investigate or plan an experimental investigation. First, you can see here, ask a question, and then we have the hypothesis one. After doing the hypothesis, we have to do some experiments, whether it is working or not. If it is working, then you have to analyze the data and draw the conclusions from the experiments that we are doing. And in the last, you have to communicate the results through this one. So this is how you can communicate, or how you can do the planning on an experimental investigation. The choice of the apparatus requires careful thought. It is also necessary to consider the level of accuracy, how to count variables, sources of error, and any steps to minimize the safety concerns. So at the design stage, you should plan which equipment to use and write a method detailing how to use it. So you need to evaluate alternative approaches, taking into account any possible advantages and also the disadvantages of each approach that may help you to improve the method. So you have to add all this in your steps for planning an investigation or experimental investigation. So next we will talk about the accuracy and the precision, because for selecting the correct apparatus, the type of apparatus used in an experiment will depend upon the scale and the accuracy of the results that are required. So accuracy and precision both are the most important one. So accuracy and precision are the two ways that scientists think about the error. Accuracy, it refers to the how close a measurement is to the true value or the accepted value, and precision refers to how close measurements of the same values are to each other. Like in accuracy, you can see here on my screen also, this is the representation of the accurate and the precise values. The ability of the instrument to measure the accurate value is the accuracy, or in other words, you can also say that the closeness of the measured value to a standard value or the true value. Accuracy is obtained by taking some small readings from any apparatus. So accuracy at a particular point on the scale is, you can also say that as the point accuracy. And if we consider, you can see here on my screen, this is the example for the accuracy and the precision. Like this is a good analogy for understanding accuracy and precision. To imagine, suppose a football player is shooting at the goal, and if the player shoots at the goal, he's said to be accurate, and a football player who keeps striking the same goal post is precise but not the accurate. So therefore the player can be accurate without being precise if he hits the ball all over the place but still scores. So like that's here you can see that if he hits here, so this is not accurate but this one is precise. So a precise player will hit the ball to the same spot repeatedly irrespective of whether he scores or not. A precise and accurate player will not only aim at a single spot but also score the goal. Like in the first picture, you can see here in the first one we have, you can see here, this is the true value, or you can say that this is the you have ever observed about the bull's eye. This is also just like that. So if the player hits in the center, that means it's the most accurate and the most precise value of that game, right? So it's the accurate and the most precise one. But whenever any player hits around this one, around the central one, but they are not close to each other, so that is more accurate and less precise. Precision refers to how close the measurements are. Like you can see here we have like 8 to 10 shots that are hit by any player and they are close to each other. So whenever the values are close to each other, like we have 4.54, suppose we have 4.53 and we have 4.52. So all these are the precise measurements. They are very close to each other. So that's why you can say that in these values precision is very high. But you can see in the last picture the player hit here and none of them goes in the center because the center one is the most accurate one. So this picture is not accurate and is not precise, and the repeated measurements that they are doing here, they are also scattered or spread on the board. They are not close to each other. So that's why this one is not accurate and also not you can say that the precise. And precision and accuracy, if we discuss more about that, we have, suppose we have a data that is collected and the value is obtained to the true value. Like for example, in any titration, like in any acid-base titration, the volume the acid that is used to neutralize will be like 14.10, right? 14.10 centimeter. So whenever any student performs the experiment, when carried out, the student recorded the results of 12.45 and then we have 12.55 and then we have 12.5 centimeter cube. So these are the results that are recorded whenever any student do the acid-base titration. So this data is precise as the repeated values show a very small difference, but it's not accurate because the actual one is 14.10 centimeter cube. Another student will also record, and whenever he record, the value is 14.3 and then 14.0 and then we have 14.1. So this data is not precise as the repeated values show a larger difference. There is a larger difference between the repeated values, but it is accurate. More accurate means as the it is more closer to the true value, because the true value is 14.10. so you can see here in the difference the true value between the true value and how close the measurements are. The first data here, this is more precise because they are more closer to each other, and the second one, this is more accurate because they are more closer to the actual or the standard one. So this is the difference between the accuracy and the precision. The next one is the equipments that are used for measuring time, mass, temperature, and also we'll also talk about the volume. You can see on my screen there are the different apparatus that are used for the measurement of time, for mass, and also for the temperature. Time is usually measured by using a stop clock or a stopwatch, and the measurement of time is particularly useful when determining the rate of reaction, as we have read about the rate of reaction in our chapter number 8. And we have some digital stopwatch that are capable of reading up to 2 decimal place, and in that we have to almost 0.01 seconds. We can also read up to this one. So mass, this is about the time, how the time is measured. By using this one, we can check the rate of reaction by this, and the units of the time that are mostly used are, first we can use the seconds, and you can also use the minutes for any type of reactions. Other units may be used for extremely very slow reactions, like maybe the resting. And the one thing that you should remember, that 1 minute is equal to 60 seconds. There are total 60 seconds in 1 minute. So this is, and through this you can easily measure the time of any reaction. Next we have thermometer. By using thermometer, you can measure the temperature, and temperature is measured by this thermometer, or we have also some digital thermometer props that are available. And you can see here, this is the glass thermometer. We have a glass bulb. This is the glass bulb that is present at the bottom, and this glass bulb is used to measure or record the temperature by contacting with a large volume of a liquid. The mercury that is present in it rises because of increase in temperature, and the laboratory thermometer usually have a precision of half or 1 degree. And there are some also digital thermometer props that are available which are more precise than the traditional thermometers, and they can often read up to 0.1 degree Celsius, like 0.1 degree Celsius. And the traditional thermometers that rely upon the uniform expansion and also on the contraction of a liquid substances with the temperature, and digital thermometers can be just as, if not more accurate than the traditional ones. And the unit of thermometer is mostly that was used is degree Celsius. You can also use the Fahrenheit also, but degree Celsius is the most commonly used. Through this thermometer, you can easily measure that temperature of any chemical reaction that is happening. Next we have the mass. For the mass, we have weighing balance. Mass is measured approximately in the spatula amount, like if we are adding 1 spatula which is of a compound to 2 centimeter cube of the acid, and more accurately by using a top pan balance by this one. As you can see here, a simple balance may have low resolution, like maybe up to 0.1 gram, but if it's more precise, then you have the more precision. Resolution is basically just the smallest change in a measurement that can be detected. So wherever more complex balances may have a higher resolution, so that's why you have to use that one. So the weighing balance is used for the measurement of a mass that is present there, and mass is measured in grams mostly, right? Balance should be first stirred to 0 or set to 0 before use, and balance should also be allowed the time to settle in the final measurement reading before it is recorded. And the standard unit for this one is kilogram. You can also measure in the mass, but the standard one is the kilogram. In chemistry, we mostly use the grams, which are most often used. So 1 kg is equal to total 1000 grams. We have 1000 grams in 1 kilogram of any mass that we are measuring. So these are the equipments that are required in our laboratory for the measurement of the time, for the measurement of the temperature, and also for the mass. And for the measurement of the pH, we have pH scales, or we have some universal indicator paper that are more accurately with a digital probe. So however, on the pH scale we have 0 to 14 pH is present there, and on that we have also calibration that may be required before using a digital meter of measuring pH. So this involves using the known standard to check the values through that one, just to check whether it is working correctly or not. So you can also check the pH by using the indicator paper or the digital pH meter. Next, we will talk about the equipments that are required for the measuring volume. So volume can be measured by using a beaker, by using a measuring cylinder, pipette, or a burette, and the equipment used like for example, a beaker could be used to prepare a water bath containing 100 centimeter cube. Like if you want to measure 100 centimeter cube of water, so you can use a beaker, but it could not be used to accurately measure 25 centimeter cube of any liquid that we are using. So for generally, using a measuring cylinder will often provide a sufficient level of accuracy, and that's why you have to use, or you have to check whether or which apparatus is appropriate for any type of substance that we are going to use that. So you have to check whether it is working or whether it is not. So that's why you have to check the apparatus that we are using for the measurement of the volumes. You can see here on my screen we have different apparatus that we are using in our chemistry lab. So for the measurement of the volume, we have beaker, and the beaker is here. You can see we have graduated cylinder or measuring cylinder for measuring the liquids. Then you can also measure it by using pipette, right? So it depends upon what type of experiment you are doing or what accuracy you needed, so you have to choose that apparatus according to that one. And the first, you can see here, this is the flask, and the flask is mostly has a neck that is present there. So this is the indication for the flask. We have pipette bulb, this one that is mostly used for the sucking liquid in the pipette. We have watch glass. Watch glass is mostly used for in crystallization, and also for mostly the purpose of evaporation. Then we have beaker. In beaker you can easily measure the volume of any substance. In graduated cylinder or volumetric cylinder, you can also measure the cylinder. We have test tubes. Test tubes are there for doing any type of chemical reactions. You can do any type of chemical reaction in these one. We have rubber stoppers. Rubber stoppers are mostly put on the top of any type of beaker or any type of flask, just to make a closed container, or whenever the reaction is happening, so that the closed reaction will be there and no more gas or any type of particles will be moved out of the flask. Next, we have a wire glass. Wire glass is mostly placed on the tripod stand, like you can see here. This is the clay strand, or you can say that the tripod stand on which we put the wire glass, and on this wire glass you have to put the watch glass or any type of beaker or something like that which you want to heat. And burner, you can see in the last, this is the burner. Burner is mostly used for the heating purposes. We have a ring stand. In this ring stand you can add, or you can put the burette, and burette is mostly used for the acid base titrations, in which acid is added in this burette. Next, you can see here we have a funnel. Funnel is used in the evaporation process, filtration process, sorry, not in evaporation. And then we have pestle and mortar. Pestle and mortar is mostly used for the crushing and the grinding of any type of solid. And crucible and the cover, this is used for keeping anything without contact with the air or any type of moisture. Next, you can see here we have thermometer, we have graduated pipette, and we have also ceramic square that is present there. So all have different functions. We have crucible trunks that are used for holding any type of substance that is hot. So these are the equipments that are required for any type of chemical reaction or experiment that we are doing in our chemistry lab. So these are the three variables which I also talk about earlier. So to ensure the experimental work, there are three main types of variables that are used. First we have control variables, then independent variables, and then we have the dependent variables. If first we talk about the control variables, these are the variables that is kept constant, or you can say that it kept same during whole experiment or whole investigation. A control variable is a variable that is kept constant throughout an experiment, like as for example, consider a student who wanted to investigate how the type of metal changed the rate of reaction when added to the sulfuric acid. So to give their repeatable results, as the rate of reaction is dependent on both the concentration and the temperature, so they would have to use the same starting temperature and concentration for each in experiment. So the temperature and the concentration therefore are the control variables in this one. So it's important to control all the variables except for the independent ones, so that will allow to measure the dependent variable or the results, and also determine which factor is causing the effects which are observed. And some examples of these control variables that we use in any experiment, like for example we have temperature. So keeping the temperature constant all the time or same throughout the experiment is the control variable, right? Next we have, maybe in some experiments we have light intensity, keeping the amount of light same throughout the experiment, that will also be the control variable. And next you can also do this by using humidity. We have some more examples like the water. You have to provide the same amount of water through all the experiment. Then you can do with the pressure. So all these are the examples which are related to the control variables. Next we have independent variables. Independent variables are the conditions, as you can see here, that are changed in an experiment, means they are variable or that is altered. They are variable and they are altered during the whole of our experiment. So in this case, in the examples of the independent variables in our chemistry, like for example the pH of a solution is changing. The examples include, we have the pH of a solution is changing before and after the reaction. Like in case of a neutralization reaction, before the reaction we have acid and a base that have opposite pH, but whenever the reaction happens they neutralize it. And next you can say that we may have the more examples of this one. We have the density of the substance, you have the time at which the reaction happens, that also the independent. And next we have in this the volume, that is also included, the volume of the water or the volume of the container that we are doing in this one. And next we have dependent variables. Independent variables, this is a variable that changes in response to another variable, and that variable is measured during a scientific investigation. Like for example, we have a plant growth. In the plant growth, the amount of sunlight is independent variable and the growth of the plant is the dependent variable, because it depends upon the sunlight. Whenever the sunlight changes, right, so then the growth of the plant also affects. Next, if we talk about the test score of any student, the amount of sleep you got, how much you studied, and how hungry you were are all the independent variables, and that also affect your test score. Dependent variable. And walking speed, this is also independent variable. Drinking the coffee is the independent variable, and walking speed is the dependent variable that depends upon that one. So these are the variables that we are that you should know before investigating any type of chemical investigation. Next we will talk about the purification and the separation techniques that we are using in our chemistry. We have some standard separation techniques in our chemistry. A mixture can be separated by using physical processes. So because it's not a chemical reaction that happens in the mixture, so different type of mixtures require different standard techniques. That includes by using, we have some different, and we will also talk about these by one. So first we have a suitable solvent. By adding any suitable solvent, you can separate a mixture. Second, we have filtration. Third, we have crystallization. And next we have two different types of distillation that we will discuss in this. First, we have simple distillation, and next we will talk about the fractional distillation. About the fractional distillation, we have read also in the extraction, in the chapter of extraction of metals. So fractional distillation is mostly used for the petroleum and the crude oil. And the last technique for the separation and purification is chromatography. Chromatography mostly refers to by use separation. So now we will talk about each of these techniques one by one. So before moving towards these techniques of separation and purification, you need to know all the following terms and the terminologies when describing the solution. So first we will talk about that terminology about the solutions, and the first one is the solvent. The solvent is the liquid in which a solute dissolves. Like, this is just the liquid in which we dissolve any type of solute, and the example of this one is for example, we have a water. Water is a common example of the solvent. The next one is the solute. The solute is the substance which dissolves in a liquid to form a solution, and this solute is mostly present in the solid state, and this one is used to dissolve in a solvent. Like, you can say that this one is added in a solvent to form a solution. So the example of this one is we have a salt that is present in the seawater, and that salt is the solute. Next we have a solution, the next terminology, and solution forms whenever the solute and solvent is mixed or whenever it is added. This is the mixture formed when a solute is dissolved in a solution. So solute plus solvent makes the solution, and the example of this one is the seawater. Seawater contains the salt and the water that is present in it, so this one is the solution. Next we have soluble. The word soluble means that the substance that will dissolve, like salt in water. If you add the salt in the water, it will dissolve, so that is known as soluble substance. And insoluble is another substance which is not soluble or which is not dissolved. Like the substance that will not dissolve is the insoluble, and if you add the sand in the water, that is insoluble one. Next we have filtrate. Filtrate is the liquid or the solution that has passed through a filter paper. Like, for example, this one is the funnel, and so in this funnel you add any type of solution. So the one that comes from the funnel or the filter paper and goes into this beaker, this is known as filtrate. So this one is the filtrate that is present in our beaker that passes from the filter paper. So the example of this filtrate is the fresh water, or you can say the fresh coffee that comes in the cup after moving through the paper. Next we have Next terminology is residue. Residue is the substance that remains after evaporation, distillation, filtration, or any other similar process. Like for example, we have this filter paper. After filtration or after evaporation, what will happen? The substance that is present there on the filter paper, that is known as the residue. Residue is basically the remaining substance that is present after the evaporation, distillation, filtration, or any other similar type of processes. So the ground or the coffee grounds in our filter paper are the example of this one. And another one, if you want to separate the sand from the water, what will happen? The water will move in the beaker and the sand will stay in the filter paper. So that sand is the residue and water is the filtrate that is present there. So these are the important terminologies related to the solutions or the separation techniques that we will do today. So first, now we'll talk about the separation techniques that are present there. First one is by using a suitable solvent. So the first technique is by using a suitable solvent. For example, you have to separate a mixture of solid. A mixture of solid is present there, like there are two different types of solids that are present in a mixture and you have to separate them. So for that purpose, you can use a suitable solvent, like by the difference in the solubility that can be used to separate the liquids. So the principle behind it, the difference in the solubility. So you have to use a suitable solvent based upon the solubility of any type of solid that is present in it. For a difference in solubility, a suitable solvent must be carefully chosen. Only the desired substance should dissolve in the solvent. Other substances or the impurities in the mixture should not dissolve in the solvent. Like for example, if you want to separate out the mixture of a sand and salt. Sand and salt is the example. You have a sand and salt, that is the mixture of this one, and you have to separate the sand from the salt. Water is the suitable solvent because water is soluble in the salt is soluble in the water, but sand is insoluble. So these are the terminologies that will help you. Salt is soluble but sand is insoluble in the water, so you have to use a separate or a suitable solvent for the separation of any type of liquids or any type of solids that are present in this one. The next technique is the filtration technique. Filtration, this is the second one. In this technique, this is used to separate undissolved solid. Means that if there is undissolved solid that is present in any solution that is not soluble, so we have undissolved solid that is present in a solution or in a mixture of a solid and the liquid or a solution. Like for example, you have to separate the sand from the water. The example of this one is sand from water, the separation of the sand from the water. So a filter paper is placed. This one is the filter paper, as you can see here. So you have to place it in the funnel above another beaker, and you have to add in this filter paper the mixture of the water and the sand particles that are present in another beaker. The filter paper will allow only the small liquid particles to pass through the filtrate, and the solid particles that are too large to pass through the filter paper, they will stay behind on the filter paper. So you can see here the sand particles are called as the residue because they are present on the top on the filter paper. They can't filtrate or pass out, and the one that passes from the filter paper to the beaker, that is known as the filtrate. So this is the filtration technique that is helpful or that is useful for the separation of the substances that are not soluble in the water, and the liquid part that passes through the filter paper is called the filtrate, and the solid part that remains after the filtration is called the residue. And the useful products could be either the filtrate or either the residue. That depends upon which instrument, or you can say that the which reaction you are doing. And the care is needed to avoid disposing of the wrong part. For the very fine solid, filtration can be carried out by using a specific funnel and also a vacuum flask. We have some stand through which you have to do this one, and this is how the filtration happens and filtrate separate a insoluble solid from a liquid of any mixture, we can say that from any substance. The example of this one, or for the separation of this one, the component 1 should be undissolved. This is the component 1, and the component 2 should be the liquid. The one should be the solid that is not soluble, and the other component in the filtration we have a liquid. These are the most important things that I am talking about right now. This should be insoluble or undissolved, and the second one is the liquid component that is present or that is there in the filtration. So filtration separates the solid, which is the residue, and the liquid, that is the filtrate. Another example of this one is if you have a copper oxide and you have the solution of copper oxide. So from the solution of copper oxide, you have to separate the copper oxide from the water. Water is the filtrate and copper oxide is the residue that's present on the filter paper. So this is how the filtration happens. Next, we will talk about our third technique, which is the crystallization. So we have the third technique, which is the crystallization. In the crystallization, this method is used to separate the dissolved solid that is present from a solution. In the previous technique, in the filtration, we have insoluble solid that is present in the solution or in a liquid, but now in crystallization we have the dissolved solid. So this is the difference between these two techniques. A simple application of this is to heat a solution to the boiling and remove the heat and leave the solvent to the evaporate. In the first step, you can see here we have a solution that contains a dissolved solid from a solution. And a more common application of this is sometimes known as crystallization. This is when the solid is more soluble in the hot solvent than in the cold. So for example, we have a copper sulfate solution, right, CuSO4, the copper sulfate solution that is soluble in the water, and this solution is heated, allowing the solvent to evaporate and leaving a saturated solution behind. You can see here we have a Bunsen burner that provides the heat and the water is evaporating. By this one, the water is evaporating, or the liquid that is present in it evaporates. You can test if the solution is saturated by dipping a clean, dry, cold glass rod in the solution also. If it is saturated, crystals will form on the glass rod when it is removed and allowed to cool. So the saturated solution is allowed to cool slowly. The solids will come out. Whenever you do the cooling, the crystals will come out. This will be seen as the crystals growing, and the crystals are collected by the process of filtration also. They are then washed with the distilled water to remove any type of impurities that are present in them. Finally, they are allowed to dry, and the common places to dry up crystals are between the sheets of the filter paper or also in the drying of the oven. So this is how the solution is slowly heated to remove around half of the liquid that is present in it, and the remaining liquid will evaporate slowly. So this is how the crystallization is done, and you can separate out the solvent and the dissolved solid that is present in this technique. Crystallization is usually used to remove the water from a solution containing any ionic compound like the salt. So that's how you can do the crystallization. And in the crystallization, the first component is the soluble solid, you can see, and the second one is the liquid. So the liquid is evaporated to leave the solid behind, and the most important example of this one is the copper sulfate in the water. The solution is heated and water that is present in it evaporates, and then you have the crystals or of the salts that are present there. So you have to allow it to cool. So whenever it cools, it forms, or it will convert it into their shape. So that is how the crystallization is done in our experiments of our chemistry. Now next we will talk about the next technique. Now we have the next technique, which is simple distillation. Distillation is used to separate a liquid and a soluble solid from a solution. You have a liquid plus a solid which is soluble, and from this solution you have to separate the liquid. In the previous technique, we separated the solid, which is also the soluble, but now in this we separate the liquid or the water that is present in our solution. Like for example, water from a solution of salt water, or you can separate a pure liquid from a mixture of any type of liquids. First, what we will do, we have a conical flask that is present here, you have a conical flask. In this conical flask, you can add any type of solution from which you have to separate the liquid, like the salty water or salt water is present there. You have to heat it by the help of a Bunsen burner, and on the top we have a thermometer. Thermometer generally reads the temperature that is present on this one. Whenever you do the heating, we know that we have to separate the liquid, and the liquid in this is water, and the boiling point of the water is 100 degrees Celsius. So through the thermometer you generally check the boiling point whenever it reaches or not. So when the temperature reaches to 100 degrees Celsius, the water that is present in this salty water will convert into the liquid, from solid liquid to the gaseous state, and it will move upward. When it moves upward, and the pure water evaporates, producing a vapor which rises through the neck of the round bottom flask or the conical flask that is present here. And next what will happen, the vapor passes through the condenser. This is the condenser, and the function of this is just to cool down the vapors that are passing from this one. So the function of the condenser is just to cool down the vapors that are passing from this tube and to convert into a liquid state. So the function of the condenser is to condense them, turning it to the pure water which is collected in this beaker. So we have this distillate, or you can say that distillate is just like the filtrate, but in distillation process we have a specific term, that is the distillate. So distillation is basically done for the separation of the liquid from a solution, and also for the purification. After all the water is evaporated from the solution that is present in the round bottom flask, only the solid solute will be left behind. We have just a solid solute or a residue that is present there. So through this distillation you can also produce a distilled water, or a pure water is mostly or generally produced through this one. Simple distillation can be used to separate the products of fermentation also, such as we have alcohol and water. Whenever we do the process of fermentation, we have two products, alcohol and water, so you can separate it by using this technique. What will happen when we give the heat, the boiling point of the alcohol is 72 degrees Celsius and the boiling point of water is 100 degrees Celsius. Whenever the temperature reaches to 70 to 72 degrees Celsius, the alcohol from liquid turns into the gaseous state and will evaporate first. So this is how you can separate out the liquids from the solution of any two liquids, or also from the solid one. However, fractional distillation is more effective separation technique, commonly used when the boiling point of the liquids are close and higher degree of purity is required, such as for the crude oil. We have also read about the fractional distillation in the chapter of extraction of metals. So this is fractional distillation is mostly used to separate two or more liquids that are miscible with one another. So now we have fractional distillation. So for the fractional distillation, this is mostly done to use this separate two or more liquids that are more miscible with each other. So for that, first the solution is heated to the temperature of the substance with the lowest boiling point. Like if we talk about the previous example of alcohol and water, the boiling point of the alcohol is 70 to 72 degrees Celsius and the water is of 100 degrees Celsius. So alcohol will boil first and will turn into the liquid, from liquid to the gaseous. So first you can separate out the alcohol from a solution, and then whenever the boiling point of water reaches, which is 100 degrees Celsius, then you can separate out the water in the another flask or in another beaker. So this is how you can separate out by using the method of, or by using the principle of boiling point, different boiling point ranges. So in the fractional distillation, the solution is heated to the temperature of the substance with the lowest boiling point in which it is present. Like for example, for the fractional distillation of crude oil or petroleum, what will happen here? We have a crude oil that is present there. You have to add this into this fractionating tower. So first we have methane, butane and propane, which is the boiling point of 20 degrees Celsius. So whenever the temperature will go to 20 degrees Celsius, the substance will rise and evaporate first. The vapor will will pass through a condenser where they are cool and condensed, and the condensed liquid is then collected into a separated beaker. Whenever the temperature of the second one, which is the petrol 150 degrees Celsius, comes, the vapor will pass through and the vapor will rise and it will evaporate then. So all of the substances is evaporated and collected, leaving behind the other components of the mixture. So this is how the fractional distillation of the petroleum and crude oil is happen in our industries by using a fractionating tower or a fractionating column that is present there, and you have to provide a high temperature of mostly like 400 degree to 500 degrees Celsius temperature is provided, and you can separate out so many different fractions, 2 or more different fractions that are separated by using the fractional distillation. So this is how this is done. We have electric heater that is used when there are flammable liquids are present. So the separation of the components in the petroleum is achieved by the fractional distillation on the industrial scale, and the fractional distillation of the crude oil is not carried out in school laboratories due to the toxic nature of some of the components of the crude oil, but it can sometimes be simulated by using a synthetic crude oil made specially for the demonstration of this one. So this is how you can do that for that one. So if we talk about the previous one, you can also take the example of alcohol and water. And this, and in alcohol and water, first the boiling point of alcohol reaches and then you can condense it, and then the boiling point of whenever the water reaches, so you can separate out and condense them in the separate beaker or in any separate container. So if we want to assessing the purity of any substance, pure substances generally they melt and they, if we talk about just the pure substances, they melt and they boil at a specific temperature. Like for example, water, the boiling point of the water is 100 degrees Celsius. If the water is pure, then it will boil at 100 degrees Celsius, and the melting point of that water is 0 degrees Celsius, means it melts and freezes at the 0 degree Celsius. So this is the specific temperature that is required, and this through this you can easily set that is this a pure substance or not, because pure substance melt and boil at the specific and sharp temperatures. If is there any impurity that is present there, then the boiling point will increases, and if the impurity is present in the water, then the melting point decreases than the normal one. So the mixture have a range of melting and boiling points as they consist of different substances that melt or boil at the different temperature. So for distinguishing a pure substances from the mixtures, therefore you can use melting point and also the boiling point as the physical properties to check whether it is pure or the impure one. We can also identify the unknown pure substance by experimentally determining its melting point and boiling point and compare them to literate the values from our data tables. Like boiling points are commonly determined by the distillation process that we have done before, and melting point is usually done to assess the purity of the any type of drugs. Like for example, if we want to know the melting point apparatus, which allow you to slowly heat up a small amount of the sample, making it easier to observe the exact melting point. That is how you can assess the purity of any substance that is present in our solution, and then we can compare the value with the data tables that we have. So a sample contains the impurities that have boiling point much higher than the normal, and if it contains impurity, then the melting point will be lower or appear lower than the sample's actual melting point. So this is how you can assess any type of impurity that is present in any solution. So now we have the last separation technique, separation and purification, this which is paper chromatography. Chromatography is used to separate the substances and provide information to help and to identify them. Like the components have different solubilities in a given solvent, like different colored inks have been mixed to make the black ink. So suppose we have a filter paper or chromatography paper like this one. You have to take this one, a pencil line is drawn on the chromatography paper and the filter paper like this one here, and then the spots of the sample are placed on it. Suppose we have 2 to 3 different inks that are present there, and you have to place it by with a difference between them. A pencil is used for this as ink would run in the chromatogram along with the samples. The paper is then lowered in the solvent container that is present there like this. and making sure that the pencil line sits above the level of the solvent that is present in this one. This is the solvent that is present in this, and this is mostly, we use the ethanol for this purpose. What will happen, it will take the ink when the solvent moves upward, it will take the ink with it also. So the solvent is usually ethanol or water, but it can be other substances we can use in this one. So the solvent travels up the paper by the capillary action. By the process of the capillary action, the solvent will move upward and taking some of the colored substances with it. Different substances have different solubility, so they will travel at different rates, causing the substance to spread apart. So those substances with higher solubility will travel further than the others. Like, so when the water moved upward, and then we have to analyze the chromatogram. Now this filter paper or the chromatography paper is known as chromatogram because it has a separation of the different inks that are present on there. That's why we call it as a chromatogram. Now we have to analyze this one. Now you can see here we have three different color spots that are present, like we have purple, green and orange that are present there, and you have to check the pigments that in the ink can be analyzed by using the paper chromatography, as you can see here. So now this chromatography paper or filter paper, when the inks are separated, you now call it as the chromatogram. So the pigments of the ink can be analyzed by using this paper chromatography, and we can also interpret simple chromatograms. We can use a chromatogram to compare the substances present in a mixture to the known substance and also make the assumptions. Like the pure substance will produce only one spot on the chromatogram, and the impure substances will produce more than one stop. Like you can see here, there are three spots, so this one is impure, means two or more substances are present in it, and if two or more substances are same, they will provide identical chromatograms. And if the substance is a mixture, it will separate on the paper to show all the different components as the separate spots that is present on this them. So this is a common practice to include a known compound as a reference spot, and this can help to match up with the unknown spots, and also set up by using this one. So we can draw several conclusions from this chromatogram. Like you can see here, the spot is present here. This is the spot that we actually draw, and after that it will separate into the three different substances. And so you can also find the relative value, the RF value of this one, and through this RF value is the distance moved by the particular spot, can be measured and related to the position of the solvent front. Like we have RF value, and RF value equals distance moved by the substance by the distance moved by the solvent front. So this is the formula through which you can easily find out the RF value or the relative front. Like for example, if the spot C here, you can measure the distance by using a scale. If the spot C has covered the distance of 3 centimeter, suppose, and the spot B covered the distance of 5 centimeter, and the spot A covered the distance of 8 centimeter. So this is the distance covered by the different spots on this one. And next you have to find out the distance of the solvent front that is covered. Like this is the line that shows the liquid that is moved up to this chromatogram, and this distance is suppose 12 centimeter. So if you want to RF value for the spot C, B or A, you can do this by this RF value distance moved by the substance, and the distance moved by the substance C is 3 centimeter, and you have to divide it with the distance moved by the solvent front, which is 12 centimeter cube, like this. So whenever you do this, you can have the value. it's equal to 0.25. You can also find out the RF value for the spot B and also for the A. Like for example, for the A, you have to first write the distance of the compound A, which is 8, and the distance by the solvent front, which is 12. So you can easily simplify this by using these techniques. So the RF value is always the same for a particular substance in a specific solvent at a given temperature, and it can be used to identify the unknown substances by comparison with the reference values from any chromatogram. And we have some locating agents. These are the compounds that reacts with the invisible particles. If the spots are invisible, you can use a locating agent like colorless spots separated by the chromatography to produce a colored product that can be seen here. So this is how the chromatography is done to separate out the mixture of the inks or the colored substances that are present in any solution or in any compound. So RF value is the ratio calculated from the chromatogram and is the distance moved by the substance divided by the distance moved by the solvent front. And locating agent can be used to highlight the position of the soluble colorless substances in any chromatogram. And we have a reference sample that is used to compare the samples in our chromatography. So these are the techniques that are helpful or useful for the separation and purification of any type of substances that are present in a solution and something like that. And chromatography has produced very useful in the analysis of biological important molecules like such as sugars, amino acids, nucleotide bases, and this technique can be used to detect also some illegal substances in a blood or in a urine and to identify any contaminants that are present in a food or in a drink. So this is how you can do the chromatography by using this technique, and this is known as the paper chromatography. And we have pigments that have different solubilities in the solvent, and the pigments here, so the pigments have different solubilities in the solvent, and the pigments have different degree of attraction for the filter paper. The one which move further away on the filter paper, as you can see here, we have a spot or a compound A that is present there, that will move further away from the other substances that are present there. With her solubility will travel further than the others, means that the compound A has more solubilities with the solvent as compared to the compound B and the compound C. So this is these are all the techniques that we have done today. Hope you understand all. If you have any question, any confusion, you can ask in the comment box. Please like and subscribe our channel. If you like this content, then please share it with the others too. We will meet in the next one.